This is a video for AQA Further Pure Mathematics. This is conic sections and polar curves 3.6, converting between polar and Cartesian forms. The diagram shows a point P which has got polar coordinates r theta, and we want to convert to the Cartesian, or to find the Cartesian coordinates x and y. Clearly we can see on the diagram there that we've got a right angled triangle, so it's actually a very straightforward process to work out that x is r cos theta and y is r sin theta. So x r cos theta and y is r sin theta. So for this particular point we can see that P has got the polar coordinates 5 and angle pi by 3, and so we would have x is equal to 5 cosine of pi by 3, and cosine pi by 3 is equal to a half, so this is equal to 2.5, and y is equal to 5 sine pi by 3, and sine of pi by 3 is root 3 over 2, so this is 5 root 3 over 2. Therefore, P has got its Cartesian coordinates 2.5 and 5 root 3 over 2. Going in the other direction, we can again use the right angled triangle to get a value of r involving x and y. So clearly that's Pythagoras' theorem, so that r is equal to root of x squared plus y squared. And tan theta, we can see, is equal to y over x. Now that much is quite straightforward. However, there is a problem with the tan theta. Your calculator will always give you a value which is in the first or the fourth quadrant of the circle. So your calculator, if it's a positive value, will give you an angle in this quadrant here, and if it's a negative value, in this quadrant. However, tan theta is also negative in the second quadrant and positive in the third quadrant. So you have to really understand the fact that although your calculator might give you one result, the actual value of the theta could well be at 180 degrees opposed to that. So there are always going to be two values in this range from negative pi to pi, so we have to be a little bit careful. A diagram which tells us which quadrant we're in will help, and then we can use a quick sketch of a tangent graph to look at our two different values. So if we get a point which is in positive, and it's the first quadrant of the circle, we can see that if we need to find actually a value which is in the third quadrant, tangent diagram there says that we must subtract a value of pi from the angle on the calculator. On the circle diagram you can see there that we're coming round in this direction, subtracting pi. Likewise, if you get a negative value, so therefore that's in the fourth quadrant of the circle, and you actually want one which is in the second quadrant, then the graph looks like that, and we have to add pi to the value. and that's just turning round in an anti-clockwise direction. So care to be taken there, deciding which quadrant your point is in, and therefore whether you have to add or subtract pi from the answer on your calculator. So let's put that into practice then with a couple of examples. Here we've got 2 points A and B with Cartesian coordinates 5, 12 and -3, 4, and we're asked to find their polar coordinates. Well, the first thing we should do is to draw a quick sketch so we know which quadrant that we're talking about for each of the points. 5, 12, we could put our diagram at about this position here. So that would be A, where it's 5 along the x-axis and 12 on the y-axis. So we can calculate then R is equal to the square root of 5 squared plus 12 squared, which gives us a value of 13. So it's a 5, 12, 13 triangle there. Theta is equal to tan to the minus 1 of 12 over 5, and that comes out to be 1.176 if you use your calculator. Now that's going to be fine for this point because we want the angle to be in the first quadrant, and 1.176 definitely is. Therefore, A has got coordinates 13 and 1.176 radians for theta. B, on the other hand, is at -3, 4. So -3, 4, about this position here, where we've got -3 on the x-axis and 4 on the y-axis. So R this time is the square root of -3 squared plus 4 squared, which of course is 5. It's a 3, 4, 5 triangle. Theta comes to be tan to the minus 1 of the y value 4 divided by -3, and that comes out to be -0.927. But that's a value which is in the fourth quadrant of the circle, which is down here, and therefore we need to add on a value for that to give us that value plus pi. So we need to add pi to that, -0.927 plus pi, which gives a value of about 2.214. And therefore B is at the point 5, 2.214, which is definitely in the second quadrant of the circle. And there you can see the solution written out for you rather more neatly. And you can see there how we've used the fact that A being in the first quadrant, we don't need to do anything, although had it been that we'd got a point which is in the third quadrant of the circle, we would have had to subtract pi, shown by the diagram there. And for B, we were given a value which was in the second quadrant, so we needed to add pi to the calculator value. Well, that's the end of this video. In the next one, we'll be looking at how we sketch polar curves.